And good morning, everybody. Congratulations. You made it through the week. Another week of fantastic food safety, food quality, beautiful, wonderful food products. And a lot of what we do in this space goes unheralded. So guess what? Alan and I are going to say this to everybody here today. Thanks a lot. We really appreciate it. We appreciate all that you do. So if you're new to the food safety chat, pull up a chair and welcome. We talk about a food safety topic every single week at this time. So we live stream on LinkedIn, YouTube, and X. I got to get used to calling it that. And we sit down here to have a chat. And you'll notice here in our conversation today that this isn't a lecture, and this is meant to be interactive. And that's the best part, and that's the most interesting part of what we're doing here. Is this is an interaction. And we have a group of fantastic regulars who join us here every week and contribute to the conversation. And we really appreciate that. So thank you very much. So with that, one of the things I love doing with the chat here, and if you've been on here before, you recognize the face of this man next to me, and that's Alan Saylor. Alan is a fantastic guest, and he is the founder of the Center for Food Safety and Regulatory Services. How are you doing today, Alan?
I'm doing great. Really excited. It's Friday, and when you're semi-retired, it shouldn't matter, but it's always good to be Friday.
Well, yeah, it just when you have your own business and things like that, weekends kind of become a moot point. There's really no
That's right.
Different days of the week, and so other things just need to get done, and those seem to get done, and it all goes together. But it's all good. Tim from Tennessee, good. We see Tim post on LinkedIn of his adventures, and it seems like travel sometimes. The travel gods conspire against Tim. So glad you got back home. I saw lots of posts this week from the IAFP. I wish I was there. It looked like it was a really, really good conference, but hopefully we'll get some good input coming back from that. So, gosh, with that, I mean, really, we got a ton to jump into. So everybody, grab your glass of your favorite beverage and join Alan and I for a ceremonial drink here. Cheers.
Very good.
So as most people I'm sure have seen around the internet, we got lots of problems going on out there. So fingers crossed that everything goes okay with this. But we do local recording on this on StreamYard. So even if the transmission goes a little wonky, we'll still have the transcript and everything still available for the chat, because I know with this conversation today, you're going to want to hear it because it's an important one. And Alan always has a lot of good things to say. So with that, one of the things that you'll notice here, guys, is I'm not drinking coffee this morning. I am drinking water. And there's a reason for that, because water is our topic. And with that water, we forget a lot of times just how important water is to manufacturing food. Right, Alan?
Yeah, one of the things that surprises me, let's put it that way, as I go into various food plants, and one of the issues I ask is, what do you do with water in this facility? And you find out different facilities use water in different ways, some for cleaning, some as an ingredient, some for other things as well. And I ask them, well, then what do you do to ensure that water is safe, meets quality standards? And some of the answers are pretty good, and some leave me scratching my head.
Mm-hmm. Yep, totally. I mean, if you work in the beverage space, so for example, I was at White Wave Foods with Silk Soy Milk and other products like that, 80% of your product is water or more. And if you don't get the water right, you're in for a lot of trouble. And I have seen issues in the past where you had water qualities that weren't detected, and then you only find out about it when you start getting consumer complaints back where people are saying, hey, it's kind of weird. What's going on with your product, right? Because as we know, and this is something we talk about here on the chat quite a bit, is consumers complain when something is different. It could be better, it could be worse. It doesn't really matter what your opinion on that is. Consumers have an expectation for that product, and that applies with tap water as well. There's a certain way that water tastes, and we expect that. So if you're in Loveland, Colorado, or beautiful Virginia, or Duncan over in the wilds of Europe, it applies to everybody. So it's really, really important to maintain that. So part of this is water. Really, Alan, there's only one of two sources for our water in our manufacturing facilities. There's municipal water and there's well water. And that's about it. So those two things really kind of segment and help you determine what course of action you're going to take, right? Oh, as predicted, we got a little bit of buffering here. So while this is going on, appreciate everybody's patience for this. We'll just keep forging forward, because with water, the municipal water, I think, in a lot of ways, is a water channel that has risks with it that we really don't think about, because we just assume that water from a municipal source is safe, and that's not always the case. We have seen major crises with water in different locations. So, for example, in Wisconsin, in Milwaukee, they had a gigantic water problem in that city where lots of people got sick. Swimming pools. A lot of times you'll hear about outbreaks in swimming pools. And with those outbreaks, here, we have two Allens here.
Which is the real one?
There we go. Switch you over there. One Allen is more than enough. So we were talking about your first decision in your plant when you're looking at water, Alan, is municipal versus well water. And that really kind of starts your strategy. And even though you're using city water, it's a gigantic mistake to assume that it's safe, because as we've seen from the big water outbreak we had in Milwaukee, if you assume that, you're really taking a lot of risk, aren't you?
Well, you really are. You know, one of my colleagues in FDA said something that was very profound to me. They said that at any given moment, 2% of the municipal water supplies are out of EPA compliance. Now, what does that mean? It could be a little, that is a lot. And of course, as soon as they find they're out of compliance, they call everybody and let them know, right? No, they don't. In fact, you may find out days later, sometimes weeks later. And water is fundamental. This is why I always recommend to my clients, and frankly, it should be to the entire food processing industry, that we treat our water. We filter our water. Oh, wait a minute, the municipality does that. Well, sometimes there are failures. We treat our water. We test our water. We have the capability with simple rapid detection testing systems to ensure that the water that we're going to use, whether it is just to clean the floors or whether it's going to be something more profound, like as an ingredient, as you said, in the beverage industry, that it meets the quality and safety standards. I cannot emphasize that enough. And it can go bad so quickly. And when it goes bad and your product is impacted, let's say it's impacted from a safety standpoint, not just a quality standpoint, and then you get complaints. You get complaints from your customers. You get complaints from consumers. You have regulatory issues with the government. Well, that wasn't my problem. That was the city of blank, blank, blank. It doesn't work, does it?
No.
There's no way. You own that responsibility.
Yeah, absolutely. And I had an issue in my past where there was a municipal water source that was supplying our plant. And of course, as you said, Alan, you're 100% right. We found out way after the fact, we found out about this. And when we found out, because we started asking questions of the city, they had a pathogen issue in their water system. It was like it wasn't anything super, it wasn't like salmonella or something like this, but it was coliforms or E. coli or something in that system. And the city then said, oh crap, we need to clean our system. And they super chlorinated their entire system. They sent this giant, slug of chlorine solution through their entire system and didn't tell anybody. That came to our plant. This plant uses a lot of water. It's an ingredient in the product. And no one noticed. We weren't doing, this was a lesson learned for us and something for you to think about in your plant too. We instituted daily water tasting at the beginning of the production day. So the lab would go to a water source close to the entrance to the plant. They would pull a little sample, they'd bring it back to the lab, and they would taste it. And they were just looking for that differences in flavor associated with that chlorination, because for that issue where that happened, Alan, it went into the product and it caused massive flavor issues. And we didn't find out about it until we started getting complaints from consumers. And it was a gigantic problem. And were we able to go back to the city and say, hey, here's the bill for all our ruined product? Nope.
Well, and what is tested for? I'm sure everybody here knows exactly what the EPA criteria is for micro, or at least we may have a pretty good idea. But are there other micro things we should be looking for, like Pseudomonas? We've got interesting stories to tell about that. Also chemical. Now there, maybe I'd be a little bit more challenged to know what the EPA criteria is for chemical. but maybe I don't have to know it if I have things like a UV light system that is effective. Maybe I have carbon filtration. In your case, the carbon filtration probably would have dealt with most of the chlorine issue over superchlorination. And, this is it's a once in 100-year storm type of thing. All it takes is that one time, and it can significantly impact your business. It can actually drive you out of business. So it's, to me, a small investment. And once you make that capital investment, a lot of these systems run almost on their own. You just, like my refrigerator has a filter and the light goes on when I have to change the filter. We have those kind of systems available in food plants. Easy to use.
Absolutely. Yeah, absolutely. And like Duncan said here, good morning, good afternoon, Duncan. Ooh, new picture for Duncan. Look at him with his little coat on there. Nice. So I once worked at a place with a long distance from a water treatment plant and had to install chlorination tanks at the infeed. There were microfractures in the pipes along the way. Absolutely. Your assumption that your water system and your supplies is pristine is false. We see in the news more and more, Alan, about these giant water main breaks in large cities. I think I saw a story a few months ago about the city of Atlanta. The billions of dollars they're estimating that they're going to have to spend to dig up and replace old, damaged, corroded pipes. Now think about Prop 65 as a kind of a little food for thought around this as well. Is you have very strict limits for Prop 65 for heavy metals in your products. What if you have metal pipes that are leaching, old, nasty pipes from God knows when going to your plant, and they're leaching, let's say, lead into that water supply, and you're out of compliance with Prop 65 for lead levels in product, and you don't even know it because of that water that's going into your product. As Cortland said here, yeah, different threats from the water, absolutely. Burkholderia. A big one that I always ask about when I go to plants is Cryptosporidium. And Cryptosporidium, of course, is a parasite. And this is one of those things that kind of gets put off to the side. We look at E. coli and coliforms and, kind of the biggies in the incoming water supply. But Cryptosporidium is a gigantic threat in the water supply. Well, why is that? Well, it's because they produce oocysts and these little, think of it like a spore for a parasite. And these are extremely resistant to chlorine. So this is why a lot of times you'll see these outbreaks in swimming pools where people will bring their small children to a swimming pool and kids do what they do. And you end up with contaminated water and you get crypto in that swimming pool. And it's just like, okay, everybody out. You have to take these things into consideration to do that. So let's get Alan back here. Welcome back, sir. We were talking about Cryptosporidia. And as Cortland had correctly pointed out here, Burkholderia, a big risk in water as well. As Duncan says here too, a lot of times in food, you're really kind of limited, as you had mentioned as well, Alan, is what are the standards? And within food, if you're using water as an ingredient, you have to kind of go by those EPA standards to look at what those limits are, but it's very vague relative to that. And when you kind of look at it, who would have thought when Alan and I were a little bit younger than we are now, the idea of bottled water was ludicrous. I mean, who in the hell would pay incredible amounts of money for water in plastic bottles when all I got to do is go to my faucet and it's free? But I think that's kind of a good story around marketing. There was an issue, Alan, I don't know if you remember this one or not, in Las Vegas a few years ago, where they were producing alkaline water. And this was the whole marketing thing, right? And someone who was working in that plant didn't follow the recipe correctly and massively overdosed that water with whatever chemicals they were putting in that water to give it these properties. A lot of people got sick. People had to have surgery. I believe, people lost parts of their liver because of that issue. And, people think, water, what's the big deal? But you really need to look at those things really, really closely and do not assume that water coming into your plant is good.
Yeah. Something I think is worth bringing up, Brian, is a court decision just in the last month, I believe, where EPA was exploring and has been exploring for, I think, the last 10 years, whether to put a standard for perchlorates on municipal water supply systems. So they were going to do it. And of course, I think it was politics, but far be it from me. I'm a regulatory guy, not a political person. So it was kind of held within the agency for a long time. But unfortunately, they had published a preliminary level. Well, the court decided within the last month that, in fact, it will be requiring EPA to establish perchlorate levels and enforce them in municipal water supplies. Mm-hmm. Well, I'm not a municipality, so why do I care? Well, I think we know where that's going, and that is going to mean that there will be an expectation that the water that we use is going to have perchlorate limits as well. Well, what is a perchlorate? Well, perchlorate is formed when we use chlorine or a chlorine compound, and there are organics in the water. And, many water, particularly surface supplies, there are organics. And so there will be perchlorates probably formed. Now, what is the level? And does the municipality have the ability to, really is one of the more common ways to remove it. So should we be paying attention to that? Is that our responsibility? Or, Brian, maybe we just sit and wait and see what happens. I don't know. What do you think?
Never a good course of action, that's for sure. The whole perchlorate thing came about and really it was California, the whole thing with rocket fuel. So, rocket fuel can contribute to this. And to your point, right, it was all the rage for a while, and then it just kind of went away. But those things pop up. And part of this too is the chemistry testing we're used now. As we talked about before, we used to test in parts per million. Now it's parts per billion. And we're finding stuff in there that we didn't even think would be there before. Here's a weird little story. So here in Colorado, lots of people like to live in the mountains. And it's beautiful and gorgeous, but there's problems that come with it too. I had some friends who owned a home, and their water supply to their home, they had to have a well up in the mountains, of course. And their water was contaminated with, get this, uranium in their water supply. Yeah. So they had to install special filters in their house to remove the uranium from the water to make it safe to drink. Now, guess what? Now they have filters in their home that are concentrating uranium. You're concentrating uranium in these filters. How do you get rid of that now? Good question. Things you never even think about in your water supply until it happens to you. Craziness.
That is so true. So it's the same whether it's uranium or perchlorates or some other chemical contaminant that you're trying to control. So yeah, you've got the filter media. Now some of this stuff you can simply put it in an oven or an autoclave and it will just burn off, so to speak. It's a crude term, but it burns off. Some of it does not. I don't think uranium is going to go anywhere if you have it concentrated in a filter. So exactly. I guess you look for the Nevada repository, right? See if you can get access to it. But getting back to this whole issue of water, there's also the issue of supply. Now, we know about supply management, right? We have supply management programs. It's required by the preventive controls regulation under FSMA. And yet, do we think about water and managing the source of the water, the supplier of the water, as a supplier? We should. How many of you go down to the local municipality and look at the water treatment system? They probably wouldn't want you in there, but my background is in water and wastewater management. I've been in many of those, and I think it would be a smart idea, even if it is a public tour, to go and see that. The other thing is food defense. How easy would it be to contaminate the water supply? Believe it or not, it is probably one of the least protected of all of our infrastructure systems, and it's going to affect a huge number of people. And again, as you said, Brian, I'd like you to speak more on this, okay, so it's the municipality's fault. They should either be protecting it, they should be treating it right, but what happens if it goes wrong and it affects you?
Yeah, exactly. So as Cortland is saying here, right, is weekly reports. I wish we got weekly reports. I mean, normally when we see this as consumers, and this takes place in the plants as well, is if you get a yearly report from your municipality, right? We get it as consumers in the mail, and of course, everything is fine. But Cortland's giving us some good information here. So He's also saying the FDA has requested those reports. So to your point, Alan, go talk with the municipal system for your water supply for your plant. If you're a plant of any size, you're probably a big customer for them, and you're 100% right. They are a supplier. They are a supplier of, in a lot of cases, an ingredient into your plant, and you need to make sure that that supply is safe and that they're managing it correctly. And so, looking at it from a food safety, food quality, and to Alan's point here as well, is a biosecurity system. We've seen this in movies lots of times, where bad guys try and contaminate the water supply. Well, guess what? They're giving real bad guys ideas on how to do that. So we have to be really, really careful. The other piece of this as well, Ellen, is the city's responsibility stops at that backflow preventer at your plant, right? From that point forward, it's you, baby. You're responsible for that. And in the different standards, so SQF and such, they have it in there. It's like, okay, you need to check your backflow preventer once a year, and they ask for the records showing that, and that's about the extent of it. But you need to be looking for hidden risks in your plant and going around and finding these things. I was telling Alan a story here earlier when we were prepping for our show today of a company I used to work for in the past, and they wanted to go in and replace some drain pipes and other pipes under their floor in the production facility. So major undertaking. Right? You don't want to do that if you don't have to. So they had to dig out the dairy tiles, go down underneath the floor to get to these pipes to see what was going on down there. And get this, Alan, when they got down there were no pipes. The pipes were gone.
Oh my.
All that was left was holes in the mud where the pipe used to be. The sanitation chemicals with this old plant had completely eaten away those pipes. There was nothing there. The maintenance guys were flabbergasted when they saw that. Yeah. So you have to look at those pipes in your plant. And if it's an older plant as well, what are those pipes made of? Right? Are they lead pipes? What are they?
Probably in most cases. I've seen the same thing in wastewater. The topic today is water. So I've seen wastewater that has left facilities, and the only reason it got from point A to point B is because there was a hole in the ground. There was no pipe there anymore. But we'll stay on topic here. Your point about in-plant is really important because we are not plumber experts in the plumbing code, and yet you really need to know this because there's a backflow preventer. Is it the right kind? The idea is not all backflow preventers are created equal. And I can't tell you how many plants I've been into where there's a backflow preventer. There's 20 of them. There's 50 of them. The plumbing people say, oh, you need a backflow preventer. This is the least costly one. This will work. It is a backflow preventer. But in our facilities, we have to meet the plumbing code. And there are specific backflow preventers for specific uses. And do we know what they are? You should. If you don't, find out and learn. And on the internet, you can learn a lot. So do not be lulled into a sense of complacency that a plumber that should have known the plumbing code that applies in your area has put in a backflow preventer and it's the right one. Some of these do not work in the situations that they're put into.
So that we're all on the same page here. What is a backflow preventer, Alan?
Well, backflow preventer is to protect against cross contamination, and it's that simple. But the problem are the lines that the backflow preventers put on, is one side pressurized? Are both sides pressurized? Is one side not pressurized? Do you have a nozzle on the outlet that puts back pressure on the back pressure valve itself? And because of that, some of these backflow valves will not work if back pressure is put on them. So this is, it's cross contamination. That's what we're talking about. And it is so easy to do. And this almost leads us as a segue into the topic of, well, what isn't water water? Water in a plant is water in a plant until it isn't. So what does that mean? Do we have different kinds of water in the plant? Do we have good water and bad water? Do we have treated water and untreated water? Do we have reused water? Do we have CIP solution water? Well, that's right, we do. Yeah. So there's all kinds of different water that we don't want mixed.
Yeah, absolutely. And that's super important in that plant is, and so in the dairy industry, if our guests here on the chat work in the dairy industry, a prominent reuse of water in plants, in dairy plants, is what they call cow water. So when you make cheese, it's about a 10-to-1 ratio of milk to cheese. So that other 90% is waste. And that goes to the stream where they dry it and they collect the powders out of that, and then they filter it down, and you're left with what they call cow water. And it's not treated water, it's impure. And so plants will use that water then and say, well, that's a giant waste not to use that water. So look, how can we use that in the plant? So they'll use it for rinsing out milk tanks when they first arrive and they've been unloaded in a plant, or they'll use it for other sanitation purposes. But are those the correct uses? Because a lot of times the people who are using that water think water's water, and all you need is a maintenance person to cross-connect some lines between cow water and pasteurized pure water that's going into product, and you got a problem.
That is, and I bet if we went into any plant in this country, we would find cross connections. They're not always easy. I mean, this is a spider network. Not only do we have pipes for product, or sometimes they are under vacuum, sometimes they're under pressure, but we have all kinds of pipes for water, and we have pipes for wastewater. And how do we know that we haven't cross-connected, or a plumber accidentally? I call these the midnight riders. The midnight riders are the maintenance people. We can't live without them. We love them. We sometimes hate them, but whatever it is, they are fundamental to the operation. But many times they're doing things in isolation, and respecting their professionalism, which we really should. Things are likely done correctly, but is there a follow-up? Are they trained? Has anybody checked with them? Do they know some of not just how to fix things, they're probably good at that, but why, and what are we trying to achieve, and the possible impact of them cross-connecting improperly. So I think it's really a focus that we should spend more time talking to our maintenance people. Well, wait a minute, I'm a quality person. That's not my responsibility. Yeah, it is your responsibility to talk to your maintenance people, understand their level of understanding, and share with them. You'll learn things from them. They'll learn some things from you. This is about protecting the water. And protecting the water, is the food defense. How many of you in your vulnerability assessment for food defense included water? I'd be curious to hear.
Yeah, it kind of broke up there, so I'll repeat that for everybody else. So in the comments here, guys,
On the chat.
let us know how many people have identified water as part of your food defense plan. Let us know what you're thinking around that here. So something else to think about here, and as we're waiting for Alan's connection to kind of come back here, is sporadic contamination in your plant. And don't forget, because water is an ingredient, it's in all kinds of different storage locations in your plant as well. Welcome back, sir. So we're talking about sporadic contamination of your water supply in the plant. And I had this issue in the past. I was working for a company where we were producing fresh mozzarella. And with fresh mozzarella, one of the steps in that process is use a lot of water, because you mold the cheese and then you put it into cold water to make sure that it retains its shape. So we had a giant holding tank that was there by that system to hold water. And this was a relatively new product we were making at the time. And one of the other problems with water is Pseudomonas. Pseudomonas loves water, and that's something you need to be looking at in your food safety plans and thinking about relative to water and how you're managing that. So it took us months, Alan, to track this down, because we were getting Pseudomonas contamination in the fresh mozzarella. And we couldn't figure out where in the world it was coming from. We were cleaning everything. CIP systems are working wonderful. It ended up being a water storage tank. And what was going on in that tank is you had contamination high in the tank with the condensation up inside. And as that tank would fill, it would reach that Pseudomonas up there, and the Pseudomonas would go, hello, and it would get in the water. And then as you run during the day, it would bring that level down and contaminate. And it would repeat that cycle. And it drove us nuts until we figured out that that was the problem.
Well, I can tell you that somewhat similarly, but separately, I was managing a $150,000 study for a part of the food industry. and water was really important in this. It was a validation study, which finally did get done, but we went through $150,000 as the first phase, and you could just as well taken that money and thrown it out a 10-story window because we had massive Pseudomonas problems. Nobody thought to check the incoming water supply. We assumed it was okay. What's the problem? I mean, it came from a reputable large city, and what happened is the Pseudomonas overgrew all of our Petri film plates. I know it dates me a little bit. I don't know if anybody's using those anymore, but we couldn't detect and find what we were looking for because Pseudomonas was massively present. Yeah. So even though that isn't exactly on track, I agree with you that Pseudomonas is an overlooked microbial contaminant, and it's a great indicator of other potential problems.
Yep, absolutely. And so Duncan is saying here, you should treat your water just like your ingredients, locking and controlling access to your water 100%. Cortland here brought up routine passivation of equipment. So generally, and Alan is an expert in 3A and equipment maintenance and selection. And passivation generally, Alan, is a one-time deal, right? I mean, you put some new welds in equipment or you get new equipment, you passivate it, acid treat it, these types of things, and then that's it, right?
Not exactly.
No?
Sometimes, in most cases, you're hoping that's true. But what happens over time, let's say that we've got a 20-year life cycle on a piece of equipment. And as you said, Brian, we've done the installations. We had to do some things on site, put some welds in and things like that. And then we passivate using nitric acid, or there's other ways of passivating depending on what the metal is. But over time, because of our cleaning and our chemistry of cleaning, the introduction of acid-based sanitizers certainly is almost a mini passivation every time that you run the sanitization cycle. However, we still have to be aware that over time, we will lose that passivation and we will have to do it again if the equipment lasts that long. Sometimes we're a little tougher on the equipment, and the life cycle of the equipment is such that, yes, one time is all you need because by the time it's due, you're ready for new equipment.
Interesting. Wow. That's what I love about having experts like you on the chat, Alan. I learn new stuff every time. So thank you. So kind of our different things that you need to look at in the plant are points of use, right? The ubiquitous hoses, right? They're everywhere. They use those hoses to spray down stuff and everything else. And then those hoses may get rolled up and hung up, which is great, or they may end up on the floor, bad, but no one ever cleans those. No one cleans them. When's the last time you saw maintenance taking apart or cleaning the spray heads from the water hoses? Never. I never see that.
No. And, why should you? That high pressure will blow everything off, Brian. So therefore, it's got to be clean, right?
Oh, yeah.
Well,
never mind.
Let's talk about this. Let's talk about the little physics here with pressure, right? In other words, if you have high pressure, then it should evacuate anything that is behind it, right? Therefore, if you have a high pressure situation, you shouldn't have to worry about what is after that because it's all going to get pushed out. Well, what we know is that because of the micro, if we did a micro analysis of the pressure dynamics in a nozzle or in a high pressure pipeline system, the pressures are not constant. And therefore, you actually get cavitation, you get changes where if something is going out in a high pressure stream, I will guarantee you there is something coming back. We just don't know it. It may be very small. So when you think about pressurized lines, pressurized hoses, nozzles, things like that, where we don't really think there's a problem because everything is being pushed out and we know what is in there is safe. So we don't care about what's on the outside. The outside will get back in again. So this idea of laying hoses in a dirty bucket on the floor, or where, it is just a matter of time until that contamination on the outside gets back inside, which intuitively doesn't make sense. But I can tell you that from a physics standpoint, it does occur.
So Cortland's making some good comments here as normal. Thank you, Cortland. So swabbing of hoses. Yeah, best practices. Do plants normally do that? Probably not. Probably not too much.
Probably.
Other things to think about in your plants. The ubiquitous leaks in your roof, right? Letting water in, and you'll see, a big rainstorm, you'll have this gigantic puddle in your main walkway that all the employees walk through. What is that water tracking through the plant? There have been many a recall caused by leaky roofs where product came through. Overhead water condensation. A lot of times, Alan, I'll hear from plants, oh yeah, well, we've got these cold water lines running through my hot plants. I will insulate those pipes to keep them from sweating and causing issues in my plant floor. Maybe. A lot of times what I've seen, Alan, I'm curious about your comments on this. Those wraps that you can put around pipes sometimes are worse than the problem, because you'll get condensate inside the insulation. And now you have stuff growing inside of that as well. So you're just making it worse. Does that make sense?
Well, it makes sense, and I can tell you that I've seen it. I'm sure some of you on the chat have seen it. But I'd rather have the wraps, if you get them, than the condensation. And to your point about how many people, or to the core point about how many people swab the nozzles, how many people swab the condensate?
Yeah.
I would love to see what we would find. I think we know what we would find is it would be a bad story. And so wrap the pipes, and then, unfortunately, that's a one and done thing, a little like our passivation, but it's not, because after a while there's a life cycle, and you look inside, you're going to find black mold. You're going to find all kinds of interesting, creepy and crawly things, and you have to then switch it out. And it is such a it's a major challenge. It's almost like tearing the floor up, not quite as bad, but almost as big of a challenge to replace these insulated systems that are trying to reduce the condensate. And I just want to characterize one thing about your roof leak. That's a catastrophe. Yes. People think that's an inconvenience. That's a maintenance problem. We'll get to it. Don't worry about it. Just put a pail there. We'll step around it. I'll tell you why it's a catastrophe is because of what's on the roof. What's on the roof is our bird roosting system. Every food plant builds a special roosting system on the roof, right? Because we want birds on the roof. Oh, that's right. We don't want them on the roof, but they're there. And we know that the wild bird population is carrying salmonella, and now we know it's carrying bird flu, but that's another topic. But the salmonella is on the roof of every food plant in this country. I will guarantee you, if you would swab up there, you're going to find it. As long as it's up there, we're okay. Once we get the leak that, Brian, you characterized, and it gets in the facility, salmonella of all of the things is the least that I want to go up against. I mean, I'll go up against Listeria, Pseudomonas. You give me any kind of other pathogen, I'm willing to take it on, and we can probably win that battle. Salmonella, the chances of winning that battle once it gets into the facility are about 50-50.
Yeah, good point. And don't forget about your extraction systems in your plant for water as well, your drains. So if that salmonella gets into your drain systems in your plant, good luck. Good luck getting rid of that, right? And now imagine if you're down in, Houston, and a massive hurricane comes through and everything is flooded, and all of a sudden that water comes back out of your drains into your plant and everywhere. You have a massive contamination problem.
Well, I can tell you that there's a I think this is not an internet story. This is a true story, and I can tell you it's true because you can tell the color of my hair. Is that about 30 years ago there was a dairy plant in a major city, and they had a salmonella problem because it was a dry plant. And dry plants tend to have more problems with salmonella because all the rest of the things go away. In a dry plant, Listeria is less likely. All these other things are less likely to be a problem. And if they are, they're relatively easy to get rid of. Salmonella became a problem, and they finally located about where it was in one of the walls. They had a knockout there, so they just walled over the wall. They put about a 3-foot spacer in there, and they walled over it, and their salmonella problem went away. Oof. And they were happy. And they operated the facility for 10 years with no salmonella problems. Then a new plant manager came in, brought some new ideas, thought they needed some new equipment, needed the space. When he found out there's 3 foot more behind that one false wall. He told them to tear it out. Within 3 months, the salmonella was back. Oh. And It'd been 10 years. Now, they did not do the whole genome sequencing, so I can't say that it was the same. But my belief is it was probably the same salmonella living in those walls for 10 years. And then when they took the false wall that had sealed it out, it came back. And it came back with a vengeance. What happened to that facility? It closed its doors. It could not ever again, because salmonella then got out of that one area and got into other areas. And they just essentially had to shut the whole facility down.
Wow. So your facility is, super important along these. So some other things that you need to be thinking about here as well. So there's two main systems in your plant for water that you need to be thinking about. And again, this is where quality people kind of go, this is maintenance. No, you need to understand these systems. Is your filtration system coming in your plant? Number one is, do you have a filtration system coming into your plant? Because as Cortland is saying here as well, is there was green algae growing in a purified water tank, and they were sending it straight to filling. Oops, right? And they didn't catch it. Terrible, right? So your filtration coming into your plants. Oh, I've got city water. I don't need to. No, you should be filtering your water coming into your plant, because you don't know if something happened there that's going to impact it, or if they're doing a good job of treating it in the first place. The other system is your boiler system and how you're treating the water. Boiler management and maintenance is an art in and of itself. And the people that do that work, it's amazing what they're able to do to keep those boilers going for decades and not be damaged. But if they're doing it incorrectly and using the wrong chemicals, those boilers will eat themselves from the inside out. And there have been cases with companies I've worked for who did improper boiler maintenance, and they had to shut down the whole plant to replace boilers as an emergency because they had no boiler capacity. It was all gone. Culinary steam. If you're using steam injection systems in your plant, oh boy, that's another good one. Around all of this as well too, and we've been kind of talking about this indirectly, but I want to make it explicit here. I don't want to miss this point. Is your actual water quality itself? How is your water? We know, and I'm sure Cara, if she's listening to this, or her ears are going to perk up somewhere, is chemical companies know this very, very well. If you have hard water with lots of minerals or particulates, and you're trying to clean and sanitize with that water without taking the proper steps to neutralize that, you're fooling yourself, because it's going to be extremely ineffective. So you need to understand those solids levels in your water supply, so that do I need to add chelating agents or other things in those sanitizing and cleaning chemicals? Otherwise, they may not be working and you don't even know it.
Yeah, and you'll deposit some of those minerals that are in hard water on equipment, and getting mineralized deposits off. You think that biofilms are difficult. You try and remove mineralized buildups. It's very difficult. But I do want to go back to your boiler for one other point.
Yeah.
And that is that if I can't find submerged inlets or improper backflow preventers anywhere, I'll find them in the boiler system. And you say, well, wait a minute, that's off limits. Why are we even worried about that? That the water gets heated and it is safe. The problem is the boiler has a boiler water makeup tank. And that's where the fresh water is added, and then the boiler draws from that as needed. And many times we just don't pay attention to that. Why do I want to go into the boiler? It's not maintained. The last person that went in there, we've never ever heard from them again. So nobody goes in there except those people that have to maintain it. I will guarantee you need to look at that system, the water system in there, because it has a potential for cross-contamination. And there are boiler chemicals. It's easy. I won't mention names here, but there are companies that make quick, rapid testing systems that anybody can use to determine if your chemistry is correct in the boiler and in the water. So I would encourage you, if your maintenance people don't have one of these kits, reach out to Brian or I. We can give you recommendations. That's a must in the boiler system.
Yeah, you're
right.
Make
sure your water is going to be safe.
Yeah, it's completely overlooked, right? Yeah, it's hidden in the back of the plant. It's by the maintenance shop. Freddy Krueger lives back there. And we ignore it, and it's a huge mistake. With your incoming water system too, you need to be looking at it of what type of system do I have? Am I relying on filters? Am I relying on UV? What are the different systems that are being used? And with the PM around that, UV lights have a life cycle. And what people don't realize is if you have a light that is rated for a year, at the beginning, it's not putting out as much radiations as it did at the beginning. At what point in that curve of effectiveness is it starting to go down? That's when you need to replace it. Don't wait until the end. It's too late. As we talked about crypto, is the UV going to be effective with the oocyst for the crypto? No, it's not. It's going to laugh at the UV. It's going to laugh at the chlorine. So in a lot of plants, you need some type of physical filtration system. So you could be using filters, which are very expensive, or you could be using a diatomaceous earth or other system to filter that water coming in there to remove those type of parasitic risks associated with that water. Should you be doing that, right? And this is where there's whole companies out there, as Alan had said as well, who specialize in this. It's very worthwhile getting to know these companies because water is a art and a science both of how you manage it, and every plant is unique. Also remember that the water is different at different times of the year. Here in Colorado, you have the spring runoff from the mountains. The water quality is different at that point in the year. Where's that water coming from? Is it a reservoir? Where's it coming from?
One of the things too is, okay, so where does that water come? Well, it comes from the plant. Where does the plant get it from? Many of our large cities, where some of our large plants are on river systems. And so what is discharged upstream becomes the input for the water treatment downstream. Is that correct?
Right.
And people are starting to be quite concerned because what are we finding in the discharge, which is also then maybe 50 miles downstream, the intake from my water treatment plant? We're finding hormone levels. We're finding medical prescription drugs. We are finding COVID. We are finding PFAS. And what about microplastics? And all of a sudden, we're getting to the point where I'm overwhelmed, Brian. I don't know if I can go on anymore. But the point is, let's focus on what we can do, not what we can't do. And also what's real versus what's on the internet. Microplastics. Okay, that's a hot topic. Microplastics in the water. Should I be doing something at my plant to make sure that there's no microplastics? Until I see more about the toxicity, and it's not that I want microplastics in my water, but until I see more about the toxicity and what this all means, let's not go over the edge, so to speak, and put in massive when in fact they may not be needed. And it sounds like we're saying two different things, but we're actually not. You have to be reasonable and practical. And so let's do that. I'd like to hear some feedback from you and from some of the people that are joining us about some of these other things, not the common chemicals, not the common micro, but some of these things that are on the fringe right now.
Mm-hmm. Yeah, exactly. It's a good point. And thank you, Cortland, for the USP reference here for everybody. Cortland's always awesome here on the chat. Thank you, sir. Cortland also brings up another good point here is, okay, water quality for your plants. What about the water quality for your suppliers? What if they're supplying you things? Are they looking at their water? And to his point here, if you're buying products or ingredients for your product that come from overseas, their water standards are different. Are they going to meet your requirements here in the U.S.? Nice point, Cortland. I like that. So treating or not treating is something that you need to be thinking about for your water supply. And you need to be thinking about it, to Alan's point, which is a really good one, is reasonably likely to occur. That's our standard. Now, you can't go crazy. What are the things that you need to be addressing and how are you managing this? With your water system, you need early warning indicators and at the point of use, right? So if you have all these pipes snaking around your plant, you need to be looking at your water supply at the point of use. So as we were talking about earlier, that hose. So you need to be looking at that water at that supply source. And there's nice, simple little rapid tests. So something I used to use in the plants is just a quick sanity check because they're cheap and they're easy to use, are tests like ColaSure, which is a simple colorimetric test that's been around forever. You put a little bit of water in the test, and if it comes back and changes color, that means you've got coliform in your water. Just like in our sanitation processes, if you have coliform, that's an indicator that other stuff is probably there too. So if you get a positive result, it's like, uh-oh, we got a problem.
Yeah, one of the things that, and maybe I'm not as complimentary to the municipal systems and the people that operate them as I should be because they're professionals. But one of the things that you may want to do is not only go down there and see if they would give you a tour, even if it's just a public tour where you can't see everything, is develop a relationship with them. And Brian, you said something early on about your experiences, and my experience has been the same, is that when things happened, they do not make it public unless it is super serious. And therefore, maybe if they understand how sensitive your system is to glitches in the water that they're supplying, maybe they will let you know ahead of time. In other words, we cannot have, if what is the criteria? If I'm a municipal person and you're the plant, Brian, don't tell me to call you every time I have a little glitch, because I have glitches every day. What is the criteria that you need me to call you for? In other words, and then we'll have this little discussion. So develop that relationship. I think that could really go a long way, and we haven't talked about that yet. So
Absolutely. And again, as Alan said here at the beginning of our chat here today, water is an ingredient. You need to have a verification and auditing program essentially with your water. So go and meet with those guys. Tell you what, does it hurt anything to invite them to your plant? If I was working in a water treatment plant and someone invited me to come over and take a look at the food plant, I'd be like, awesome. Yeah, I'd love to see your plant. Building those relationships. And we talk about this time and time again on the chat, right? Because we want to beat this into your head. You don't have to know everything, but you do need to know the people who do know what you're looking at. There are people out there who are experts in water who understand these things. You need to be able to have that relationship to be able to pick up the phone. And let's say, for example, in some of my past scenarios, and Alan, what you brought up here is 100% right, is if the municipal has an issue or a hiccup, and now they know who I am and what I care about from a food safety standpoint, they may very well pick up the phone and say, hey, Brian, heads up, we're doing a big PM on our water system tomorrow to shake some stuff out of it. Because water systems do this every now and then. They will send flushes through to get gunk out of their systems, as we talked about before. And it could just be buildup of sediment or something innocuous. But they may pick up that phone then and call you and give you a heads up, and you can shut off that water supply to your plant and let that pass by, and it doesn't impact you.
Yep. And I know we're getting toward the top of the hour. I did want to raise one other subject, if you're okay, Brian, and that is water reuse, which is becoming more and more common. And sometimes it's not a matter of choice. We have to do it. So as in the Midwest right now, we've got so much water, we don't want to know what to do with it. And with the hurricane, it went up into New England. But over time, it's actually, we've got the opposite problem. And even in the United States, but in some of the areas where you have suppliers, is that, what are they doing to reuse the water? Are they doing any treatments? And one of the interesting things is we're going to be reusing water more and more. How many times can I cycle water from its original incoming, capture it, treat it as needed, and getting rid of the micro is actually the easy part. The chemistry is what I need to understand more if I'm going to reuse water. And then how many times can I do that before I've got these unusual chemical byproducts, these free radical things that are really making it very bad for me to reuse that water more than 2 or 3 times. What do we know about that? Because there are companies out there that say, hey, I'll bring a skid in and I will save you 40% on the amount of incoming water. And then you can, publicize that. You're really green, you're sustainable. This is fantastic. The board of directors loves it. The plant manager loves it, except the science. What is the science? I was involved in one of these operations in the state of California. And I can tell you that state of California really, really asked hard questions. And we got down to it. We were able to figure out we could only reuse this water X amount of times before the chemical byproducts became at such a concentration, we couldn't remove them anymore. And these were then starting to reach toxic levels. So water reuse, Codex right now has adopted a whole new guideline on water reuse in food processing. There is FAO, which is a food and agricultural organization, has a safety and quality of water use and reuse in the production and processing of dairy products. So there's lots of resources that you can get, but don't be lulled into a false sense of security that I'm going to achieve sustainability by going to zero net water usage. And I see a lot of companies making that claim. I'd love to figure out how they are doing that. Should we use reused water? Yes, we should. But it's not all, glamour and lights. There's a lot of things we have to know that our management doesn't. And we're the ones that need to provide them with those answers.
Yeah, that's a really, really good point. I'm glad you brought that up, Alan. I work with lots of companies who have B Corp certification. And that's one, oh, that's kind of cool. It's like Alan's like floating away. I love it. There's a lot of companies. It was just a really freaky visual to see you floating away. But where the hell was I? Oh yeah, B Corp. And there's a lot of companies out there that have sustainability goals built into their company charters, and water reduction usage is generally in most of those plans. And you bring up some really, really good points there around that. The other final topic here before we summarize this for everybody is, like we know under our food safety plans, who are you selling your products to? Are you selling to sensitive audiences? Are you selling to infants or children? We had talked about this a little bit around these sensitive groups. And what is defluorinated water? What is that, Alan?
Well, that's interesting. And why would we even care about fluoride in the water? I mean, I want fluoride in the water because I grew up on a farm where there wasn't any. And so my dentist bills as I got older were just out of this world. But let's talk about, what does it have to do with food? In many cases, it has nothing to do with food. But I will tell you that in infant formula, if you're the few of you that are involved in the infant formula, FDA has a regulation that says you must reduce the fluoride in your incoming water supply to as And I think that is a surprise. Now, even if we're not in the infant formula world, it's like, why is that? I thought fluoride was a good thing, or at least.
Darn connection. There we go. You're back. So kind of breaking up, Alan, but what I caught on that was FDA has levels for fluoridation in the water relative to infant formula. And if you work in infant formula and you're not aware of that, wow, huge problem. So do you have it in there, or how can you remove it? I don't even know how you would remove it.
Yeah, it's for most of us, we don't have to worry too much about it, but it is another thing that in the, as a professional, we need to know, if you decide to go to work in the infant formula world, you've never had to worry about fluoride before. And no. I've managed lots of water quality and safety programs before. And so fluoride is never a part of it, except in the infant formula industry, where it is critical, and FDA is becoming very strict with this.
Interesting. So with our chat today, let's kind of bring this back and summarize this for everybody. Alan, what would you like everybody to kind of leave with today? Closing thoughts.
First of all, I think every food plant needs to understand their municipal system, the quality and the parameters of the incoming water, and I believe they have to have a treatment system. It may be minor, a UV light system, or it may be significant, but I don't think there is a plant out there that doesn't need some type of a treatment system for water.
Agree. And you need to make sure and educate, as it is it often in the case of food safety, you need to educate the management of the plant why this is important, because it gets overlooked so much. And I've had enough issues in my past where water has bit me that I know you need to be looking at it. So definitely you need to be thinking about these things, because ignorance is not bliss in this area, right? Things that go missed in food safety eventually are going to come back and get you. So with that, guys, we'll bring our chat to a close here for this week. I think we got to our goal here, Alan, which is with water. This is something that you don't think about, but our message here today is, if you're working in food safety, you do. You need to be thinking about water in your plant, how it's used in your products, how it's used in your plant, how it's reused in your plant, how it's treated, how it's filtered, how it's managed at the points of use. You could spend a week going around in your plant just looking at all these different elements here associated with that. And with this is why this chat is so fun as well, Alan, is all the amazing resources from our fellow participants in the chat here who are giving everybody great ideas on where to go relative to this. And with that, we'll bring our chat here to a close here this week. And thank you, everybody, for attending. And thank you, Mr. Saylor, for attending as well. And of course, we will be back here next week at the same time. So 8 a.m. Mountain Time, 10 a.m. Eastern on LinkedIn, YouTube, and X for the next food safety chat, where I bring another amazing guest on like Alan. And I'm sure I'll be seeing all of you back here again next week as well. So in the meantime, have a great weekend. Enjoy yourselves. It's a beautiful summer. And we'll see you back here next week. And let's see. So we'll switch this out here. And we're just closing out here, Alan. So have a great weekend, my friend. And everybody have a great one, too. Thanks a lot.
Thanks, Brian. You too. Take care.